everyone. Good morning, and thank you very much for giving me this opportunity. Actually, I'm kind of worried that I have some trouble with my connection, so I want to confirm whether my voice is can be heard clearly or.
Yes, your voice is audible, ma'am.
Okay, thank you so much. Okay, I'm gonna share my screen. And I'm sorry if I have to turn off my camera during the presentation because I'm afraid it will burden my uh, internet connection. Again, I'm so sorry.
That's all right, Madam Anisa. We'll just be hearing from you. It's okay.
Okay. Um, so this is, okay. Can you see my screen now?
Yes, your screen is visible.
Okay, thank you.
You're welcome.
Wait. Yeah. Okay, so can I start now? Okay, I'm guessing I can start now. Again, ladies and gentlemen, and everyone here, thank you for joining this session. And it's such a great opportunity, and it is a great pleasure for me to be able to present these materials in front of you here. So my topic today is the data science role in actuarial science, and particularly I will present several part of our research. It is a study on paddy crop insurance. Okay, before we start, I'll introduce myself, even though Ms. Ardela already introduced me, giving me a brief introduce earlier, but I'm afraid that maybe you're hoping to know more about me. So here's my personal information. You can see in my screen. My full name is Rahma Anisa, and without particular reason, I am preferred to be called as Anisa instead of Rahma. And here is my contact. If you have any questions after this presentations outside this forum, maybe you can email me in this address. And as already been explained by Ms. Ardela, my educational background is from statistics here, both in undergraduate and graduate degree. And I am from Department of Statistics, also from Faculty of Natural Sciences, IPB University. And here's several areas that I interest. It is predictive modeling and high dimensional data, and also computational statistics. And actually, it's only several of them. So kinds of other research areas also, but particularly for now, at least, I am interested in researching about these topics. And here are the list of several of my publications. Yeah, you can see on the screen. Actually, there's one of the publications that I will explain later in my presentations. And as I said before, I will turn off my video camera. So I'm hoping it will make my presentations proceed smoothly. Okay, here is my presentation outline. So in the next one and a half hour, about 1.5 hours, I will present about the actuarial data science. So what is this, the actuarial data science? And then I will mention several machine learning algorithms that are sort of quite popular nowadays. And then I will show you the example of how we can combine the learning algorithm into actuarial science, and how we can get the benefit from it. And then I will tell you a brief story about the applied research, especially research that is conducted by me and my colleagues on crop insurance in Indonesia. And some of the preliminary results that we get from the research, concluding remark to end the presentations. Okay, so first, the idea of how I want to present about these materials, because there is a global explosion in data. It is actually already happened, I think, since 10 or 20 years before. So there is data everywhere. I mean, if we see now, almost each one of us have a smartphone, and then every time we go outside, we try to consult with the Google Maps, we access the Google Maps or Waze or any kinds of similar applications. And also now in Indonesia, there's very popular about the Grab service, Gojek, and also every time we try to look into something or researching about something, we are almost always use the search engine, and without realizing it, we type something, we want to know about something, and then everything that we put on the internet, our personal information or our behavior, it is recorded actually. And because of that, there is a massive explosions in terms of the available data set nowadays. And because of that, it is a trigger the need that many kinds of industry to be able to extract the meaningful information from the available data set that are available on the cloud or the internet or in many things. So not only that, there is a trend now that most of the people, particularly the young people, they tend to use social media actively, posting their activity, their images, and everything on the social media. So there are a lot of data, whether it is image data or audio or video, not only the quantitative data, but also the unstructured data. So there are a lot of kinds of data out there, and it is challenging and yet giving a big opportunity for many kinds of industries, including the insurance industry. And because of that, these are the challenges of that situation, especially for the insurance company. The first one is because of that kind of situation, there is a disruption to existing insurance business models. Because in one hand that there is data everywhere, and then it enable many kinds of company, maybe a startup company, to start their business also. So I mean, almost everyone can access every kind of information, and because of that, it creates a competitive market nowadays. In one hand, it creates opportunities, but on the other hand, it also create more competitive market for the industry. And also there is a data management challenge because of the quantity of the data, and not only okay, I hear some echo. Is everything all right? Or okay, I will just move on with my presentation then. In terms of data management, I mean, as I said before, the data is kind of explosive and massively available everywhere. And in order to get the useful information from the data, then it needs adequate management system. I mean, we have to pre-process the data. We have to maybe doing some feature engineering from the data in order to get the useful information, because unless we are capable of doing that, then although the data is very large, very varying, but maybe we cannot obtain any useful information if we cannot, we cannot learn from the data if we cannot do the right management of the data itself. So that is a big challenge, one of the big challenge from big data volume that have to be addressed by the industry, including the insurance industry. And the next challenge is about the data ownership, because even though we know that the data is available, but there is a doubt that who are these data belongs to actually? Is it belongs to the user, or the company can use it as well as its own property? So that's the kind of one kind of the dilemma of the big data. And then the other thing is the regulations, especially when it comes across the border of data. For example, is when the driver travels to another country because it crossed the border of the country. And the last thing is the data security and fraud. So because of the emerging situations, so we all need more security for the data, because we know that everyone can access the data. So because the data is available everywhere, then there is a challenge for the industry, for the insurance company to provide high security system to protect the data, that as both data of the users, of the customers, but also the data of the company. And a part of that challenges that I have been explained before, there are many kinds of opportunities. There is a large opportunities actually that can be exploited by the insurance company. The first one is because of the data is available everywhere and is accessible. Then we can acquire a better understanding of the consumer's behavior and also the market behavior. Because of that, by creating a better understanding of the consumers, then we can create a more like a personalized product perhaps that can more satisfying for the customers. And also we can predict the market situation, which product that the consumer will be like, or what about the willingness to pay of the consumer of the particular product, and etc. And also, as I said before, it can enhance our existing business models, or we can also utilize the available data set to redesign products. We can also interact with the consumer. We can create a task perhaps, like a campaign, what kind of campaign that will effectively use to get the customer, or what kind of product that the customer will be like. So we can redesign and develop that kind of choices, and we can provide that and test that to the plan to the customer. Okay, those are several of the opportunities, but so we have challenges, but we also have the opportunities that are promising for every one of us. Okay, so what is the role of actuary there in the middle of the situation that arise nowadays? So I read about the terms of actuarial data science. As we already know, perhaps that now the terms of data science is kind of very popular everywhere in every industry. So the terms of data science, data scientists, and machine learning is very happening right now. So actually, it is also part of the actuary. So there is a term actuarial data science. The difference is in the terms of traditional actuary, it is the combinations of several disciplines. It consists of mathematics, probabilistic statistics, and also domain knowledge of the field, of the product and the customers. And if we evolve into actuarial data scientists, actually we still the same, like we combine the statistics, mathematics, and domain knowledge, but we add more skill. That is more closely to the programming. So I once read that there is a need now, there is a demand for the actuary to also understand the computer programming, the code, like use Python or R, because that is very useful for the actuary to, if we understand the code and then we can develop the algorithm, we can use the algorithm, we can simulate the product. Although we can always hire people that already expert in that area, but it will be useful if the actuary themselves understand about the process, about the technical process. So it will be beneficial if the actuary also learn about creating the program and this simulations and everything related to that matter. And I want to add something that previously maybe in the 1990s or something, actuarial science always closely related to the data. So if people say about the data-driven approach, actually the actuarial science always do that since long time ago, before there is a trend of big data and everything. Because if we try to relate that matter, actuary always learn from the distributions of the customer, and then learn about develop the policy based on the existing data sets from the customer and etc. So actually the actuary already learn from the data, but now since there are a demand of the technology, and because the data is mostly digital and something, there is a need for the actuary to also learn and understand, even though you don't have to be the most expert in this field, but it will be useful if the actuary also understand about the programming. So here are the several examples of machine learning algorithms that are quite popular. There are support vector machines and tree-based method and so on that you can see on my slides. But first, I want to also explain that in general, the learning algorithm can be divided into two types. Perhaps some of you already know it as well. The first one is the supervised learning. And the second one is the unsupervised learning. So in supervised learning, basically, we try to model something based on the historical data. So we know the response variable, we have the predictor variables, and we kind of develop the relationship between those. And then we try to predict using the new data set. So there is a benchmark in the model, in the training model, and then we finally can use the model to predict the new data set. While in the supervised learning, we don't have the benchmark. We don't know the response variable. Like if we are doing the classification, the example of the supervised learning perhaps is the classification tree or random forest, or perhaps the discriminant analysis and support vector machine, or neural network. It also includes in the supervised learning. So this is includes in the supervised learning. While on the unsupervised learning, as I mentioned earlier, that we don't have the benchmark, so we don't know what we don't know the classifications of the data, but we want to group the data based on its characteristics. So we don't have the benchmark whether a particular observations have to be grouped into the first class or the second class or what class. And the example of the supervised learning is the cluster analysis. So we don't know in cluster, we just try to group the data based on its similarities without knowing or having the information that a particular observation is included in a particular group. So here's the type of the machine learning algorithm in general, and there are so much more learning algorithm that we can find. If you Google or search on the internet, and you can use code from Python or R, and there are lots of packages that provide us with the learning algorithm, many kinds of learning algorithm. And apart from that, there's also ensemble learning. So in ensemble learning, we try to combine the learning algorithm from different kinds of learning. So as in bagging algorithm, we do the resample from the data set. We do the resample from the data set, and then maybe n times. So we have n model, and then in the end, we use the combination of the prediction from n model to get the final prediction. So we combine it. Usually we use the majority vote in the bagging algorithm. Sorry. And in boosting, it's similar to bagging, but in here we kind of give weight in order to get a better prediction. So there is a particular weight that are assigned to the observations in order to boost the predictive accuracy. And also there are stacking algorithm in which we use also different kind of base learner and then combine it and then use the final prediction based on the combination of the several machine learning algorithms. So by doing the ensemble learning, it is an effort to get the better result rather than use only one single learning algorithm. And also there is a super learner algorithm. So there are a lot of learning algorithms that we can use, and we can try. And these all, most of these are available on the software. So we don't have to worry to how to use that, as long as it's quite popular, I am quite sure that it's already available on the software like the Python or R or perhaps other software. But most of them using the programming code. So that's why there is a need for you to also understand about the programming code. And here we have the resampling. So why resampling is also important? Because it is part of the learning algorithm. I mean, like when doing bagging algorithm, we use the bootstrapping inside the bagging algorithm. And also in our effort to create the best prediction model, we use cross-validation usually to be able to create a model that have a good accuracy and good sensitivity and specificity, because sometimes the model is only good when we are predicting the data that we use to train the model itself. So when we are trying to predict new data sets using the same model, sometimes the prediction is not as good as before. And when that situation is happened, it means that the model we are developed is overestimate. So there is a terms overestimate. So this is to avoid overestimate model. So we in cross-validation, we try to split the data into training data sets and testing data sets, and then change the role of the testing and the training, like until every observations is getting the role once as the testing and also as the training model. So they kind of use all the data sets as the training set and also as the test set, and then we can calculate the error based on the cross validation. And the bootstrapping is basically it's just resample with replacement from the data. And there are more learning algorithms that I don't mention here, so feel free to search for more learning algorithm that is out there and available. I'm pretty sure that will be very useful if we can utilize this learning algorithm into our research or our develop when we are try to develop something. Okay, so here's the example of applying the learning algorithm on actuarial science. I'm sorry. Okay, so here's I show you the article entitled "An Ensemble Random Forest Algorithm for Insurance Big Data Analysis." So I highlight these words, analyze the potential customers. So as the information before in the first slides, I think. So we can get a better understanding of the customer behavior. So in here, in this paper, they are trying to analyze the behavior of the customer and then try to get the potential customer. So it's usually related to the campaign of the company. So if we are developing a new product, or we are try to increase the sales of particular insurance product, perhaps, then we can use the data of the customer, and then we try to predict what kind of customer that will buy a particular product, and what kind of campaign that will be suitable to market this product. And here they are using the ensemble random forest algorithm in order to get this their objective here. So this is one of the example of how we can apply the algorithm on actuarial science. And in fact, in the insurance company, they did something like this routinely. I mean, like every month and every day, they have a target customer. They have a campaign strategy. So this kind of strategy is quite often to be used in the insurance company to increase their sales. And this is the second one. So here they use the data analysis with predictive analytics, even though it doesn't really mention here. Yeah, but this is also the example of how we can apply the learning algorithm on actuarial science. And I actually put the citation on the back of my slide. So if you interested to learn more about these examples, you can always look at my reference. Okay, here's the next one. So this is also the discussion of machine learning applications in non-life insurance. So like as I mentioned earlier, in the as a part of the global explosion of the data, most of us tend to use applications such Google Maps or Waze or anything. So there is a data from us or for the others, from the driver. They have the data of the traffic jam. They have the data of the people usually go to one place to another, and etc. So based on that data, we can develop the knowledge about the risk of one particular person of having accident in some areas. I mean, if someone apply to if someone intend to buy the insurance product, and I mean like the vehicle insurance perhaps, and we can always look at the profile of him. Maybe we can see where does the person live, and then we can see how is the traffic jam there, how is the rate of the accidents there, and is there any particular place surrounding the person's house that like very crowded or very dangerous in terms of the driving. We can always check that because we have the data. Okay, and here's the next one. They use the classification and regression trees here also to improve the product of the insurance company. Like the other thing that they mention is by using the video conversations or the phone call, because there is a customer service in the insurance company that usually stand by like 24 hours a day, 7 days in a week, and they are having conversation with the customer every day, every time, and the conversation is being recorded usually. So that is the big data as well that can be useful for the company if the company can manage to the data. So by digging the information from those kind of data, the insurance company at least can get the information about what kind of product they should improve, and about how the customer feels about their product, and etc. Okay, that's the example, and I'm sure there are a lot of other examples out there I don't put here. And this is the application. So by after we kind of take a look, a brief read from those example. So here's the summary, the key points of application of big data in insurance innovation. So according to here, Zhang and Guo in 2020, we can use the situation of the big data. We can apply it into insurance innovations. The first one is we can expand the depth and breadth of insurance product innovation, and then we can improve insurance product pricing accuracy. As I said before, that we can improve the predictive modeling, the predictive accuracy with many kinds of learning algorithm. And there is the realization of precise and differentiated marketing. This is related to the consumer behavior, because there is a chance for us now to understand more about the customer, about what they want, what are their preference, and about the profile of the customer. So we can differentiate the marketing and create a more personalized product for them. So that we hope that by doing the personalizations of the product, then the customer will be more interest, will have more interest of the product. And then we can improve the quality and efficiency of insurance services, because we can always evaluate about the services of the insurance company. For example, like the previous example in the customer service data. And also there is opportunity for us to improve risk control and anti-fraud errors because the data is recorded digitally. If we can do something about it, we can do the grade system, then we can always improve the risk control and anti-fraud efforts because the learning algorithm can also be used to detect the fraud. And you can check that on the Google Scholar or anything. We can find that there are many research to predict the fraudulent occurrence. Okay, that is my what I want to say about the current situation of big data and what are the challenges and opportunities and how we can apply the learning algorithm, like combine it into the actuarial science in order to get the better improvement in the actuarial field. But there is one thing that I want to also emphasize here, that even though we can use the data-driven approach here because of the data is available everywhere, relatively available everywhere, we can learn everything from the data, we can extract the information from the data, but again, it doesn't mean that we don't need the traditional approach. Like we still, it still be powerful to have the, sorry, it still be useful for us if we use the distribution function in order to get the right pricing of the particular product of the insurance product. And also it still be powerful if we know the actual distribution of the customers, like whether the customers is whether the customer's preference is want to have like more higher price or lower price, about the willingness to pay, in terms of the willingness to pay. Because if we work on the distribution, then as long as the distribution is approaching the actual distribution of the population, then it will be powerful for us, because only by looking the particular data sets, there is the chance that if the data only represent a particular group of the customer, then there is a chance for us to do some error also. So there is the main point that I want to emphasize here, that in doing the learning algorithm, the predictive modeling, there is always an error that we may encounter. So although I was a sort of like promoting the learning algorithm, but still the traditional approach is very powerful. So what we should do here is not by leaving one approach, but we have to combine it. So it should complete each other, because we know that each approach has to have a disadvantage, and because of that, what we're trying to do is by offsetting the particular disadvantage of an approach by doing another approach. In this case, we try to combine the traditional approach and the actuarial data science approach. So we have to combine. We cannot depend or rely on only one particular approach. So in order to get the best result, we always does not depend only on one approach. And also there is an issue in particular learning algorithms, such as the neural network or random forest. It is not an interpretable model. So that's why we always have to combine the modern approach with the conventional approach. So that's the point. And The next thing that I want to explain here is I want to share about the applied research that I did with several colleagues of mine. And the title of our research is Enhancing the Paddy Farmer Income Sustainability with Crop Insurance Policy. And we did this research about 2000 in the late of 2017 until now. So what I wanted to show you here that in this research we are trying to do the learning algorithm that I already explained before into our research, and also we still use the knowledge from the traditional actuarial field also. So we combine it here. This is one of the examples that we did. So this is the research team, and this is the head, the principal research. Our team head is Ms. Dian Kusumandingrum from Prasetya Mulia University, and this is Valentino Agusutomo, also one of the researcher from, and also the lecturer from Prasetya Mulia University. And I am sorry if there is a noise because it is the rain is just falling here. I'm hoping it is not disturbing much of our of my talks. And here is me from IPB University, and we do the research under the supervision of Professor Ken Sengtan, and I guess you already met him maybe a few days earlier. He's from Nanyang Technological University of Singapore. So it is very nice, and it is very, it's such an honor for us to work together under his supervision. And also in doing this research, we also consult with the researchers from the Ministry of Agriculture. They are Dr. Sahat Pasaribu and Dr. Rizatus Shofiati. Both of them are from Ministry of Agriculture Indonesia. And before I start to share our experience in conducting the research, I would like to acknowledge first all the institutions that that support us, especially the READY project. They have been very generous to always support our research for the 3 years of period since the late of 2017, and also the University of Waterloo for supporting us. And here's our institutions here, and also the Asuransi Jasindo for collaborating with us in providing the data and doing the discussion over the research period. So why we are interested in doing this research, particularly in crop insurance, it is because Indonesia is an agriculture country. So there are 57 million hectare agricultural land in Indonesia. And there are 33% of the total workforce in Indonesia is working on the agriculture sector. And this includes the 13 million households with main income from cultivating paddy. So there are a lot of people, households that are engaged in the agriculture industry. And unfortunately, most of them, I mean, I forget the number, but many of the households that are engaged in the agricultural activities, they are considered as a poor household. So that's why we are trying to address the issue that there is some paradigm that being a farmer is not making you rich. So that's why we are trying to do the research about crop insurance. And because we know that their income, the 30 million households, their income is vulnerable to various risk factors related to the crop insurance, related to the crop. to the crop field. The first one is fertilizer usage, farming method, and etc. And that particular factors can be controlled by the farmer itself, like fertilizer usage. They can choose whether or not to use the fertilizer and what kind of fertilizer that they can use. And the farming method also, it is their choice of the farming method. But there are other kinds of factors that they cannot control, such as the occurrence of pests, diseases, weather factor, and the other things that I am not mentioning here. Because of they are vulnerable to also to the factors that are uncontrollable by the human. So that is why the government of Indonesia launched the crop insurance product. It is for protect the farmer from the risks that I already mentioned before. So here is the brief explanation about the crop insurance product. Or here we also the name of the product is Asuransi Usaha Tani Padi, or AUTP. And there are also other type of crop insurance, like for not only for crop insurance, not only for paddy, but also for potato or chili and many kinds. Also the cattle, like lamb and goat and perhaps cow. So there are a lot of kinds of the crop insurance that already launched by the government through the Ministry of Agriculture. And Jacindo is appointed or mandated by the Ministry of Agriculture to run the insurance product. So here's the brief summary of the paddy crop insurance product. It is firstly introduced in 2012 in order to protect Indonesian farmers. And because not only pest, disease, and also weather factors that are affecting the outcome of the crop field of the farmers in Indonesia, also we know that Indonesia is prone to disaster like flood and mostly flood and drought. So sometimes there are years that have more drought season, and there are years also that have very extremely rainfall during the year. So that kind of situations could trigger the loss to the farmers. So that's why to address the issue, the government introduced the crop insurance to protect the Indonesian farmers. Although introduced in 2012, but they had to exercise and do the pilot project and something and see if the crop insurance is fit to the farmers or not. So actually, it is launched in 2015. So by the year of 2015, then the product is launched. Before that, even though it is already introduced, but the product is not really established before. And the policy protects farmers with land up to 2 hectares. And it covers crop failure due to floods, droughts, pests, and disease. And the indemnity depends on the severity of the damaged land area. So, in this particular product, they use the indemnity-based insurance, and they calculate the indemnity depends on the area, the size of the area that is damaged. For example, if a farmer have 1 hectare of farming land, and because of the flood or anything, then his or her farming land is then being damaged, about half of it. So this product will calculate the indemnity based on the loss. And in this product, they only cover the loss if the damage is exceeds or larger than 75% of the farming land, of the total farming land. To be exact, not 75% of the farming land, but the 75% of the natural size of the land. I mean, we called it as percile. If you term, it is percile. So it should be larger than 70% of the percile. If it is satisfied, then the farmer can get the paid off from the insurance. But if the loss is less than that, then the farmer will not be paid off. So that's the constraint, one of the constraints of this insurance product. And farmers could earn a claim up to maximum payout of 6 million per hectare. So if one farmer have a 2-hectare farming land, then he can get at most 12 million for his or her farming land. So the sum insured here is as much as 6 million per hectare. And this is the premium. So the Ministry of Agriculture, they determine that the premium should be 180,000 rupiah. But because the objective of this product is to protect the farmers, then the government doesn't want to burden the farmer by and force them to pay the premiums. That's why the government give a subsidy of 80% of the premium. So actually, even though the premium here stated as high as the 180,000 rupiah, but in practice, the farmers only have to pay 20% of this. So the farmers only have to pay the 20% of this value, and it should be equal to 36,000 per hectare. So as we notice here, for some of us, it may be not very, I mean, it is quite cheap, right? $36 per hectare per planting season. It is quite cheap, but there are a lot of obstacles that making it not very easy to make the farmers buy this particular product. So there are issues with the socializations and there is issue with the mistrust of the farmers. So some farmers, maybe they not really understand how the insurance work. What they understand is they have to pay something, but if something does not happen, like they don't suffer any loss, then they will get nothing out of it. So some farmers did not really understand how the logic of insurance works. Like there is a chance for them to pay something for nothing. Some farmers think like that. So that's why the socializations plays an important role here. Actually, the government make a target. There should be 1 million hectares of farming land that should be registered in the insurance, in the crop insurance. But it is not easy to achieve the target because that one reason is the mindset of the farmers, that maybe they do not believe the insurance work. And some of them also are related to the belief of themselves, like some of them thinks that maybe insurance is not halal because it contains interest. they thought it's included the interest rate and something, so they don't involve in the interest. So there are part of the farmers think like that also. And the other thing is there are very poor farmers that they don't even afford to pay as much as 36,000 per hectare per planting season. Even though if we ask them if they smoke or not, they willing to pay more for smoking habits, but they not willing to pay for the insurance. So there are part of the farmers that have to be approached differently, perhaps by the government or by the Jasindo, in order to engage them in the insurance crop scheme. But always there are other farmers that are already support with this program. So that's why we conduct this research, also to gain information and insight from the farmers and also from the extensional workers of the local Ministry of Agriculture. So for further details of the paddy crop insurance, you can look at the decree of Indonesian Ministry that I show here, the preview of it. And also you can check on the website of the Ministry of Agriculture or the official website of the Jasindo Insurance. You can look at that if you feel that you need more detail on the paddy crop insurance product. So here are the research objectives of our research. The first one, as I said before, it is for grasping a better insights about the Indonesian farmer perceptions on the crop insurance. This, we hope that by grasping the better insights, then we can address more about the situations, about the difficulties and challenge of how to implement the insurance, the crop insurance product here. And also we are trying to research whether or not there is a possibility to reduce the subsidy, because it already proceeds since 2015 and the premium never increased, and the subsidy that provided by the government is 80%, which is very, and we're afraid that maybe the government could not burden that much in the future. So, and also we kind of expecting that farmers during the last 5 years, maybe they learned and understand more about the insurance, so they have a higher willingness to pay nowadays. So we are to get the insight of that. And the other thing is we are trying to compare several alternative policies and try to propose whether there is an interesting or appealing policy for farmers that we can also develop other than the current insurance scheme. And also we are trying to analyze the possibility of acceptance of technology in crop insurance, like doing other technology like use drone or satellite images to assess to validate the loss of the farmers, maybe using the satellite to verify whether or not there is a flood in that particular area, or how much is the loss that suffered by the farmers by using drone without having to go to there. So it will make the service faster. It should improve the service of the insurance, especially in assessing the loss. And also, there is also an idea from us that we can integrate the farming card with this insurance system. So we are expecting that by integrating the farming card, maybe it will make a farmer easier to pay the premium without having to go to the extensional workers or any third parties. And the last thing that we expect is to create some policy recommendation based on our findings. So For now, I will show you, this is the survey that we conduct. So in order to get the data, because we are working with the farmer data set, not unlike the previous big data situation that already mentioned in the earlier presentations, because in this situation, we are observing farmers, and not all farmers have smartphone, and not all farmers is exposed to the current technology or any high technology. So there are farmers that are familiar with the high technology, not all of them experiencing the same as that. So that's why in order to get the data, we conduct the survey, and it involved 625 paddy farmers, and the survey was conducted in 2018 until 2019. So it was last year. And it includes 5 provinces in Indonesia, including North Sumatra, West Java, Central Java, East Java, and West Nusa Tenggara. And there are several variables that are observed in here, but I only write here only several of it. So there are a lot of variables actually, because this is very, very expensive survey, because we have to go to many other places. So in one particular survey, we try to get as much as information. Here are the several variables that we observe. The first one is about the farmer's personal description and capacity and knowledge and welfare, also their risk exposure, and also their experience of insurance product. Here are several applications. The first one is the bootstrap simulation for comparing of group risk plan and multi-peril crop insurance policy. It's published in the Journal of Physics Conference Series here in the form, here in the number this, and the other publications is presented in several international. The 2 of them are were presented in the mathematical and statistical method for actuarial science and finance last September. It was organized by the University of Salerno in Italy, and this is still we're still working on the paper, the short paper that should be published in the Springer volume. We kind of expect that it will be published there, but it haven't been published yet. So for now, I will only share with you with the first publication, because it's already been published. And this year we also work on other papers that some of it already presented in other international conference, and the other one is about to submit it in journal. And also we are also working on other paper. It's more about the policy guideline. So there are we are expecting a lot of papers and publications, because by doing that publication, we wish that we can share the information that we get from this research to the public. So here's the summary of what we do, of what we've done in the first article. The title is the bootstrap simulation for comparison of GRP and M.Si policy. So the current scheme that applied in crop insurance by the Jacindo Insurance is M.Si, or multi-peril crop insurance. So why it's called multi-peril? Because we combined all risks together in one insurance scheme. And we propose the challenger here, the group risk potential. So we provide the explanation here on the graph. I make the graph here, so I hope that you can understand better whether compared if I just show you the indemnity function. So in M.Si, this is the indemnity-based insurance currently applied by the Jacindo for the crop insurance product. So we calculate the indemnity, as I said before. It is on the losses, the yield loss from the damage area of the farmer. So I had here is the yield loss. So if a particular farmer has a damage area about of maybe 30, one third of the 1/3 hectare, so they can calculate the loss prediction from the 1/3 hectare. So, and then that yield loss will be multiplied by the sum insured per hectare. It is 6 million rupiah. So as you see here on the graph, if a farmer experiencing more yield loss here, then the farmer will get more payoff. So the claim will be higher when the farmer experience more losses. And on the other hand, in GRP that we are proposed here, in here it's a bit different because this is the area yield index based insurance. In here why it called index based, because here we choose a particular critical value here. This is the YC. So YC is the critical value that we choose somewhat that when the farmer experiencing loss equals to YC, then the farmer get the indemnity. But when the loss is higher than YC, they also will not get paid. So the situation when the farmers will get paid in this insurance scheme is when the farmers experiencing loss that is less than YC. So let's say the YC is the average loss in the particular area, let's say provinces or district perhaps. So this insurance will pay a farmer who have lost less than the average loss in that area. So by implementing this kind of product, this will support the good farming practices of the farmers and eliminate the moral hazard, because we will never really we will never be able to really monitor or evaluate whether a farmer is being honest with us or no. Like maybe the actual damage of his or her farming land is only 30% of his farmland, but because they will get paid only if the damage is exceed 75%, there is a slight chance that a particular farmer will damage his own land in order to get paid. There is a moral hazard risk there. So by applying other policy here like the GRP, so we give incentive to those farmers that take a good care, really carefully take a good care of his or her farming land. Of there is always a basis risk here, and we haven't really conducted a research about the basis risk, but it is an alternative that we propose. And in current research that we are working on the particular paper, we also propose other alternative policy other than MPCI and GRP that you've seen here. But in our first article, this is what we propose. So in order to compare the current indemnity-based insurance with our proposed GRP area yield index insurance, we use the survey data sets, and for the first year, we only finished the collecting data from Bogor and Karawang only. So there is not really much observations there, and that because of the limitation in terms of the size of the sample, we try to do the bootstrap simulations. So as I said earlier, that bootstrap simulation, in bootstrap simulation, we do the resampling from our data. So we collect a sample by with replacement, and then we Sorry, my connection is unstable. Okay. We do the resampling of several times, perhaps 1,000 times, and then with replacement. And by doing that, we generate more data sets. So we kind of try to handle the situation where the size of the sample here is very limited. By doing the bootstrap simulation, we able to generate more data sets. And here are the loss modeling. So after we do the bootstrap simulation, we have generated enough data sets, and then we try to compare both policy by comparing the VAR and the T-VAR. And the formula to calculate the VAR and T-VAR, as we can see here on the slides, is here. And here are the results after we conduct the bootstrapping. So as we can see on the slide, after we conduct the bootstrap, the graph is smoothly. Yeah, I know I don't show you the situation where we haven't conducted the bootstrap, but here the result after we conduct the bootstrap. So we can get more. We can see more about the pattern of the data histogram here. So for M.Si, the distribution tends to be symmetric, while for the GRP, it is skewed to the right. And so here, only limited, for the farming land, which is less or up to 2 hectares. And these are the results of the comparison between the FAR and the TVAR. As we can see here, the GRP insurance mitigates moral hazard. Yeah, as I said earlier, it mitigates the moral hazard here and endorse the farmers to do good farming practices to reduce crop failure. So that's why we try to propose this insurance scheme. And by doing the comparisons based on table 4 here, it is important to note that the TVAR of the M.Si is much higher than the GRP. So as we can see here, the TVAR from the GRP is only about 240,000, while from M.Si is almost 2,200, yeah, about 2.2 million. Also so there are term 1 and term 2, it represents the planting season. So we try to group the loss data into the first planting season and then the second planting season. And here's what we got. Both of either term 1 or term 2, they show that the GRP TVAR is much smaller than the M.Si. This means that the M.Si results, the higher, there is more likely to suffer a loss in M.Si because the TVAR is much higher than the GRP, especially on the large claim amount. And hence, insurance companies should retain greater amount of money as claim reserving for M.Si rather than GRP policy. So here's I've shown you only the FAR and TVAR, and I'm sorry I don't share everything here because of the limits of the time. But anyway, if you want to learn more about what we have done here, you can always consult with our article, and I write the citation on the back of the slide at the reference part. So please feel free to look at that, and you can learn more about what we did and what are the results there. Because it's just a brief summary of our research in the first year. Okay, so we reached the end of my presentations, and thank you very much for your attention. This is the concluding remarks. So the first thing that I want to say is that the global explosion of big data has been enforcing kinds of industry to adapt in new market situation, including the insurance company. So there is a demand, a high demand for every kind of industry to be able to adapt new technology and learn from the data. And the second one, actuarial science as the core of the industry, has been developing in a way to exploit the potential of data value by incorporating learning algorithm into the study and developing ideas or provide beneficial information for the decision making. So as I said earlier, we can utilize the learning algorithm into what you want to do with the data. If you want to, it can help us in making a decision and also to learn from the consumer or the market. But again, I remind you that there is no need for us to only use one particular approach. So that it will be best for us to always look at all possible approach, and we can combine the traditional and the modern approach and incorporate the learning algorithm, and also we learn from the traditional approach as well. And it cannot be neglected that there has been a demand for the actuaries also capable of handling the data and extract a sound recommendation based on it. So, sorry. Yeah, that's all that I want to say. Here's the reference that I use. You can on the link if there is available the link. And that is, I guess there is still time for discussion if you have any question. And thank you very much for your attention.